Hi everyone. Welcome to my talk on how AI and RPA automation drives operational efficiency and improves patient outcomes, where I'll provide some insights on how artificial intelligence and robotic process automation are revolutionizing healthcare delivery and enhancing clinical decision making. Before we deep dive into today's topic, let me quickly introduce myself. I'm Shiva Yachamaneni, currently working as Quality Engineering Manager with one of the leading organization in US. I have close to 18 years of work experience in software industry with focus and expertise on software development and quality engineering. During my tenure, I have worked with multiple leading healthcare, banking, insurance, and retail organizations across US and UK, providing testing and automation solutions. Let me start with today's session. Agenda for today's session will be just a minute. Yep. Let me start with today's session. Agenda for today's session will be introduction, an overview of technological revolution in healthcare, then fundamental challenges where we'll discuss on organizational readiness and other barriers, then strategic applications of AI and implementation across various healthcare domains. And then we'll discuss about exploration of AI and RPA's transformative potential in clinical and operational contexts, then implementation considerations, and finally future outlook, where we'll discuss on emerging trends and trajectory of healthcare technological transformation. Let me move on to next slide. Let me start with technological revolution in healthcare. Before we dive into this topic, let's understand what is AI and what is RPA. AI is creating intelligent machines that can think, learn, and solve problems like humans. AI uses complex algorithms and machine learning to learn from data, identify patterns, and make decisions. Whereas RPA is a technology that uses software bots to automate repetitive structured tasks that humans currently performs. These bots operate with predefined rules and structured inputs to mimic human interaction with digital systems. With the strategic integration of artificial intelligence and robotic process automation, healthcare industry is experiencing an unprecedented technological transformation. There are multiple market growth indicators which support this data. According to Grandview Research, the global AI in healthcare market is projected to experience significant expansion through 2030, whereas empirical research shows that technological integration can substantially optimize healthcare service delivery. By leveraging intelligent automation, healthcare organizations can potentially transform traditional service delivery models, enhancing both operational efficiency and patient outcomes. Now, let's explore fundamental challenges that healthcare organizations confront, which significantly impact technological adaptation and operational efficiency. First challenge is organizational readiness, where many institutions struggle with inadequate change. These fundamental issues create systemic barriers that prevent effective implementation of advanced technological solutions. Second challenge is technological adoption, considering the complexity of healthcare systems combined with high initial implementation costs, creates significant challenges for organizations seeking to modernize their operational approaches. Privacy and security concerns further complicate technological adoption. Another challenge is systemic integration, whereas organizations should be willing for integration with enhanced AI products. Last challenge usually which organizations face is workforce adoption, where there is a lag in technological adoption from healthcare professionals and willingness to navigate to emerging technologies capabilities with AI and RPA integrations. So one of the research identifies critical barriers that prevents technological integration and optimal performance. The High severity and high organization impact scores highlight the need for strategies that address these interconnected barriers. This grid provides severity, organizational impact, and patient care impact against each challenge category. So under organizational readiness, we have two subcategories, which is inadequate leadership support and insufficient technological infrastructure. So this gives clear view on severity, organizational impact, and patient care impact. So organizations must develop approaches that recognize the interconnected nature of these challenges and implement solutions that address both technical and human dimensions of healthcare transformation. In this slide, I'll talk about strategic applications of AI and RPA in healthcare. AI technologies enable healthcare institutions to optimize their resource utilization. RPA bots can perform human repetitive activities through automation and thereby significantly reducing operational costs. Another application is enhancing patient engagement by streamlining administrative workflows. AI and RPA technologies can enhance patient interaction and care by providing personalized care and automating routine tasks like appointment scheduling and sending out reminders and offering 24/7 access to health information via chatbots and virtual assistants. Another implementation area is clinical documentation and support, where advanced AI algorithms can help clinical teams by automating clinical note generation and streamlining electronic health record workflows. One more application of these technologies is in clinical support, where predictive algorithms are built which enhances diagnosis, personalizes treatment plans, and analyzing vast patient data and supporting in clinical decision making. Now let's move on to next slide. Bar chart in this slide explains effectiveness of AI and RPA implementation across healthcare functions in terms of operational efficiency improvement and clinical impact. Overall, financial optimization technologies demonstrate the highest operational efficiency gains with moderate clinical impact, whereas clinical support systems show the highest direct impact on patient care but moderate operational efficiency improvements. And clinical documentation technologies balance both operational efficiency and clinical impact. Overall, this data suggests that comprehensive technological implementation strategies should prioritize a balanced portfolio of solutions that both operational efficiency and clinical impact dimensions. Now, this slide, I'll talk about some of the key strategic capabilities of AI in healthcare. Artificial intelligence in healthcare clinical decision support leverages clinical and AI technologies to assist clinicians in making more accurate and efficient decisions about patient care. These AI-powered systems analyze vast amount of data, including electronic health records, lab results, and medical images to provide real-time recommendations, send alerts, and insights. The ultimate goal is to improve diagnostic accuracy, optimize treatment plans, and enhance patient safety and outcomes. And next use case is AI in healthcare predictive diagnostics, where machine learning and other AI technologies is analyze patient data to forecast the risk of future health issues. This proactive approach allows clinicians to intervene early, often before systems even appear. It moves healthcare from a reactive model to a preventive one, leading to better patient outcomes and more efficient resource use. And next use case is AI in healthcare patient risk stratification, is a transformative application that uses machine learning and advanced analytics to categorize patients into groups based on their risk of future health events. By analyzing a vast array of data, AI can predict a chronic disease, experiencing a complication, or needing hospital readmission. Next use case is machine learning analytics in healthcare uses algorithms to process vast amount of data to identify patterns, make predictions, and generate actionable insights. This capability is transforming various aspects of healthcare industry from patient care to hospital operations. These technologies are transforming healthcare delivery by introducing more precise data-driven approaches to clinical decision making and patient care. In this slide, I will talk about some of the key areas for implementing RPA technologies in healthcare. RPA, which is Robotic Process Automation, is a key technology for improving efficiency in healthcare. It works by automating complex administrative tasks, which helps reduce operational costs and human error. For example, RPA is used to optimize patient scheduling, which shortens wait times, and to speed up claim processing, which reduces rejected claims and accelerates payments. By taking over these routine tasks, RPA allows healthcare professionals to focus more on providing excellent patient care rather than getting bogged down in paperwork. Ultimately, implementing RPA gives healthcare organizations greater flexibility and efficiency. If systematically manages complex regulatory compliance requirements, reducing administrative burdens and risk. The strategic implementation of RPA with other systems create cohesive technological environment that supports both administrative efficiency and clinical efficiency, freeing up staff to perform higher value activities that directly improve patient outcomes. Yeah. In this slide, I'll talk about comparative analysis and impact scores in terms of implementation complexity, patient outcome, and operational impact. AI clinical decision support systems require extensive integration with existing clinical systems and has implementation complexity score as 5. AI patient risk stratification technologies demonstrate the highest direct impact on patient outcomes and has patient impact score as 5. RPA claim processing solutions show maximum positive effect on operational efficiency, significantly reducing administrative costs and processing time, and has operational impact score as 5. AI machine learning analytics presents substantial implementation challenges due to data integration requirements and algorithm complexity and has implementation complexity score as 5. In this slide, I will explain some of the critical success factors in healthcare technology implementation. For a healthcare technology implementation to be successful, a multifaceted approach is needed. It's not just about installing new software. It's about building a complex system that works well together. A critical factor is interoperability, which means making sure different systems can communicate and share data easily. This requires a strong technological foundation that uses data standards. Another key element is strategic alignment. The new technology must directly support the organization's goals like improving patient care or efficiency and have clear measurable results. Furthermore, two other crucial factors are data security and privacy and continuous adaptation. Organizations must have robust strategies to protect sensitive patient information while still using the technology's full potential. At the same time, because healthcare is constantly evolving, it is essential to be flexible and ready to learn. Finally, success hinges on workflow optimization and regulatory compliance. This involves redesigning existing processes to get the most out of new tools like AI and ensuring all new solutions meet strict legal and ethical standards of the healthcare industry. Let me move on to next slide. Data from this bar graph, this slide shows implementing new technology in healthcare involves a trade-off between complexity and impact. The most challenging factors are interoperability and data security, which have the highest complexity but also provide significant operational benefits. In contrast, workflow optimization offers best balance, delivering a high impact on both patient care and efficiency with only moderate complexity. Similarly, strategic alignment is highly valuable, offering strong impact for a relatively low level of complexity. Given these insights, a smart implementation strategy would prioritize factors that are both impactful and manageable. Organizations should first focus on workflow optimization and strategic alignment as foundational elements, as they offer the most favorable return on investment. For the most difficult areas of interoperability and data security, a more specialized and targeted approach is needed to successfully navigate their complexity. Now I will discuss about future outlook of healthcare technologies. The future of healthcare technology is all about using data and smart systems to improve patient care. We are moving towards personalized medicine where doctors can use a patient's unique genetic and clinical data to create highly specific and effective treatment plans. Additionally, AI-enhanced clinical decision support will give doctors powerful new tools for diagnostics, helping them make faster and more accurate medical decisions. These advances will lead to better patient outcomes and more efficient healthcare. These technological changes will also reshape the patient experience itself. We are moving towards more patient-centric care models that uses AI and automation to provide more responsive and personalized support. Healthcare will become a more interconnected system where data-driven clinical excellence is the norm. By leveraging these intelligent systems, healthcare professionals can make more informed decisions, reduce errors, and provide higher standard of care. To make this future a reality, healthcare organizations be flexible, will need to build flexible infrastructures that can quickly adapt to new technologies while maintaining strong ethical standards. In this slide, I will explain some of the emerging trends in healthcare technology. Healthcare is at a technological turning point, with emerging trends driving a move towards more intelligent, personalized, and efficient care delivery. The convergence of these advanced capabilities from genomic analysis to continuous monitoring, it is creating intelligent healthcare ecosystems poised to address complex medical challenges with unprecedented sophistication and precision. Emerging trends in genomic medicine. The integration of genomic data with clinical decision support systems is enabling a new era of personalized medicine. Advanced AI algorithms analyze an individual's genetic profile to identify optimal therapeutic approaches, predicting how a patient will respond to specific drug or treatments. This is especially powerful in areas like oncology, where AI can help select the most effective cancer therapies based on tumor's unique genetic information. Another usage is in continuous health monitoring. Wearable technologies and IoT devices are transforming healthcare from episodic to continuous monitoring. These technologies generate vast amount of real-time data like heart rate, sleeping patterns, and activity levels, which AI systems analyze to detect subtle changes in a patient's condition. This allows for early intervention, proactive management of chronic diseases, and a shift from reactive to a preventive care. Another usage is in immersive training technologies. Virtual reality and augmented reality are revolutionizing healthcare education and training. These technologies create immersive learning environments where medical professionals can practice complex procedures such as surgery in a risk-free setting. This allows for accelerated skill development, enhanced procedural understanding, and ultimately improved patient outcomes for patients by better preparing clinicians for real world scenarios. Another emerging trend is creation of secure health information exchange, where blockchain and advanced encryption technologies are transforming how medical data is managed and shared. Blockchain provides a secure, decentralized, and immutable ledger for health information, enabling efficient exchange of medical data across different healthcare providers and systems while maintaining patient privacy and regulatory compliance. We will move on to the final slide, which is conclusion. In conclusion, the future of healthcare is being fundamentally reshaped by technology. The core of this transformation is the powerful convergence of AI and robotic process automation. Think of AI as a brain analyzing massive amount of data to provide predictive insights and support clinical decisions. And think of RPA as the hands, automating the tedious, repetitive tasks that bog down our staff. When these two technologies work together, they create an intelligent healthcare ecosystem that is far more efficient and capable than ever before. However, this is not just about the technology itself, it is about how we implement it. To truly succeed, we need a balanced approach that focuses on both the technology and the people. We must build a culture of adaptive excellence, creating flexible systems and a mindset of continuous learning and innovation. All of this must be guided by a clear patient-centric focus, ensuring that every tool we adopt ultimately improves the patient experience, health outcomes, and access to care. Finally, we have an ethical obligation to get this right. We must ensure a responsible, ethical integration of these tools, protecting patient privacy and ensuring that care is equitable for everyone. The future of healthcare lies in developing intelligent systems that can respond dynamically to complex medical challenges while maintaining the highest standard of care. By thoughtfully adopting these transformative technologies, we can create a medical system that is more responsive, efficient, and personalized for all. Thank you. Thank you for the opportunity.